Okay, kids, we're back here in class. Returning the favor, 15b. So here we go. G. Come on. G. What's up, G? All right. If each dog applies a force of 86 newtons forward. So I'm going to draw a free body diagram. There's the sled. Okay. And we're going to let forward be this way, and it'll be positive. We're going to use positive numbers. So I'm going to call this force D for dog. Okay. And we know that each dog applies 86 newtons, and there's 6 dogs. So it'll be positive direction 6 times 86 newtons, right? Because I got 6 dogs. I also know that we're on the planet Earth. So there is a force of gravity on the object near the surface of the Earth. That also has another name. Okay, force of gravity is also known as weight. And it has an equation. The mass of the object times the gravitational field strength near the surface of the Earth. The gravitational field strength near the surface of the Earth is negative 9.8 newtons per kilogram. What else do we know? We know the mass of the sled. The sled is 325 kilograms. What else do we know? We know that since it's on a surface, the surface is supporting the object, the sled. How do we describe that in the world of physics? We say that there's a normal force. That's what we say. Normal force, Fn. And since the surface is horizontal, we know that it is equal in magnitude, but opposite in direction to the force of gravity. We also know that there's a frictional force here. Now, there's two types of frictional forces, static friction and kinetic friction. But since the sled, the object, is moving, it is most definitely force kinetic. Okay? What else do we know about this force kinetic? Well, whoopsie. I know there's an equation, but it's a very special equation. It's a limited equation. Okay, so watch this, please. Force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. That's wrong. I haven't limited this enough. Okay? Magnitude of the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the magnitude of the normal force. Okay? So this is all the given information we have. All of it. Right? Then, required. Required is they want us to find the acceleration. Now, in the past, when we've been trying to find acceleration, and it's still possible here, we've used kinematics equations. Remember the 5 equations of kinematics? We've used them in the past. But in order to use that, you need quantities like time, final velocity, initial velocity, displacement. Do you see any of those quantities? No. So that forces us to use dynamics equations. And there's only one equation in the dynamics world that has acceleration in it. Newton's second law, F net equals ma. But a few moments ago, I told you, look, kids, if you write down F net equals ma, you must always write down, oopsie, does that every once in a while. Let me see if I can get rid of it. Here we go. F net is the sum of all forces, which in this case would be force of kinetic friction plus force dog, right? Plus the normal force, plus the force of gravity on the object because it's near the surface of the Earth. We know from our free body diagram and from previous work Because the surface is horizontal, they cancel, right? So if you, and remember, this is an assignment question, so I'm not going to do the full solution. If you want to find that, that's our unknown, right? Do we know the mass? Yes, we do. Do I know F net? No. Do I have a way of finding F net? Yes, I do. Do I know force of 6 dogs? Yes, you do. Because they tell you how much each dog pulls with. So you know this will be positive, some number you're going to calculate, newtons, right? Okay. Do I know force of kinetic friction? No. But what can I do? I can calculate it. I can calculate the force of kinetic friction and then put it in here. And then remember, this is hugely important, that instead of it being in the positive direction, the force of kinetic friction will be negative some number newtons. It has to be negative. It's working against the motion. Okay, so kids, do you see what I've been telling you here in the beginning of today's lesson? Is this a one-step question? No. The days of the teacher giving you something, what is the mass of the object if the density is so much and the velocity is so much, right? Remember those wonderful days when you had an equation with 3 unknowns and the teacher gave you 2 of them and you did a little rearranging and you solved for it? Remember those days? They no longer exist for you. This is what exists. Multi-step, structured. That's why I gave you grass. People were, I don't want to use grass. I have to use grass. I have to organize myself. Okay? Multi-step structured solutions. This is your future if you want to continue in this area. Is this helping you? Thumbs up, I see. Okay, kids, bye.